So I always click on it and have it be just this tiny little rectangle.
Yeah, I found that. That's what I was
Okay,
looking for.
that's okay. So that is visible, but it's closed up. It's not expanded when your software gets installed?
Yeah, it popped up after like a minute or so.
Oh, okay. All right. Because it happens with everybody, and I just wasn't quite sure what's going on, how that works. So,
Yeah.
so are we on logarithms yet?
I'm not sure.
No? Well, what are we working on tonight?
Um, well, I thought we were gonna do some of that ACT
Okay.
practice stuff.
Yeah, for sure. Let's do that. I got a whole bunch of ACT practice tests here. Okay, there's 60 math questions and you have 60 minutes. Not that we're going to time you, but it's a good thing to know that you have about 1 minute per question on average.
Yeah.
So you kind of want to keep that in mind when you're taking the test.
Right.
Let's just start with number 1. How do you solve that?
Find the value of x. So I do, yeah, 2x plus 5 equals 17.
Okay.
And then subtract 5 from both sides. And then you're left with 2x equals 12. And then divide both sides by 2 and it would be 6. And so it would be B.
Okay. I won't say a whole lot. If it's clear you know how to do it.
All right.
All horses that run fast are brown. Horse A is not brown. Horse B runs fast. Which of those
Okay.
statements is true? I mean, F through K, which of those?
Which, like, only single one is
Only
true?
Only one of them is true.
G.
Good. Number 3. Can you see these okay? I could expand this a little bit if you can.
Oh, yeah, I can see them
Okay.
perfectly.
Cool. Okay.
How much greater than x minus 2 is x plus 5? I'm not sure how to do that one.
If I ask you how much greater than 7 is 10,
3.
how'd you get that?
7 plus 3 is 10.
Well, you subtract it. You put 10 minus 7, right?
Yeah.
Okay.
Yeah.
So that's what you want to do here. You want to take x plus 5. You want to subtract x minus 2, like that.
Okay.
Okay, and now eliminate the parentheses and solve that.
So it'd be x squared plus 7?
No. First of all,
X plus 7?
I can get rid of these parentheses without doing anything. Those
Right.
aren't affected. To get
So
rid
it'd
of,
be 7.
yes.
Okay.
Okay, I can't get this real. Okay, I can do it this way here.
Okay. Okay, so you just plug 15 in for B, so it'd be 4 times 15 minus 30.
Right. And that, incidentally, is the same as this. Okay,
Right.
let's go to the next page. Okay, number 5.
Okay. Number 5, a cartoon of 12 cans of soda is priced at $6.60 now. If the soda goes on sale 20% off the current price, what is the price of? Would you just divide by 0.2? Yes.
What did you come up with?
Well, like, never mind. I don't know.
Divide what by what? Yeah.
I said divide 660 divided by 0.2.
No, that's not what you want to do. If you go to the store and that somebody says something is 10% off, how do you figure out what it's going to be?
I don't know.
If I've got something that's normally priced at $9,
Right.
say I'm going to give it to you 10% off. Well,
It would be...
take 10% times $9. That's equal to 90 cents. And subtract it from $9. So $9 minus 90 cents is $8.10. So that's how you do discounts. And the other end of that would be taxes. So what am I going to do here if it's 20% off?
You're gonna, what's it called?
Multiply?
You're gonna multiply it by 0.2.
Okay. Go ahead and do that. Do you have your calculator handy?
It actually broke, so no. I'm using the one on my phone, though.
Okay. So, yeah, the best way we can practice these is if you're under the exact conditions you're going to be under when you take the test. So, typically, you'd want a calculator available while we're practicing.
Right.
So, what do you get?
Minus 528.
Uh-huh.
So that'd be C.
Right. Notice two things. First of all, the 12 cans of soda was immaterial.
Right.
And they frequently will do that. They will stick information in the question that is not relevant.
Right.
So don't assume that all information has to be used. There is a quicker way to get this answer. Instead of taking 20% of the price and subtracting it, it's the same thing if you take the price and multiply it by 80%.
Right.
1 minus 20. And that immediately gives you 528. In other words, it's one step instead of two.
Okay.
Okay. Now let's say the problem said that there is a 5% tax on the 12 cans of soda. No discount.
Okay, so if there's a 5% tax, don't you add it instead of subtract it from the...
Yes. In other words, you could multiply this by 0.5, and then whatever you get, you add it to 660. But that's also the same as multiplying 660 by 1.05.
Okay.
In other words, all problems like this, you can do that same trick. If it's a discount, just multiply by 1 minus the 0.2. And if it's something being added, like a tax, then it's 1 plus the 5% tax times the 660.
Oh, okay. That makes more sense. Alright, so number 6. A squared.
First of all, we have to solve both of these for A and B. What's A equal to?
That would be 8.
Almost.
Almost?
Uh-huh. As I said, the first words out of your mouth should always be when you're taking the square root of both sides of an equation.
Right.
Plus or minus.
Okay, plus or minus.
It's going to make a big difference on this problem. What is B equal to?
Plus or minus 9.
Okay. Now you got lots of combinations as to what A plus B could be. Because A plus B might be minus 8 plus 9.
Right.
Okay, so
wouldn't the answer be K?
Yeah, very good.
Because that's obviously you can't add them.
Exactly. And you won't believe how many questions on the ACT have answers kind of like this, where they put some impossible huge answer that you don't even need to check all of the possible combinations.
Right.
You know that there's no way you can add that number or those numbers to that number and get 145. So.
Right.
But you could get minus 17, you could get minus 1, you could get plus 1, and you could get plus 17.
Okay.
Geometry.
Yikes, it's been a while. BFG. Wouldn't it, doesn't it have to equal 180?
Good.
So, that would be 140?
Uh-huh.
So, yeah, so that'd be D.
Uh-huh. Let's look at it another way. Look at that angle. Is it greater than 90 degrees?
Yes.
Is it 180 degrees?
No.
So it has to be the only one they have in between 90 and 180.
Right.
But it's important that you know how to calculate this. This is two parallel lines and a transversal is what this is. Whenever you have two parallel lines and a transversal, you only create two angles, a big one and a little one. Every other angle is one of those two angles. This is the big one. This is the little one. And the big and the little one are always supplementary. So what it was basically asking here is it was telling us this angle, and it wanted to know this angle.
Right.
So you know A plus B is supplementary, so you got it.
Right. All right. If x is -3, then x squared minus -6x. Yeah. Okay, so it would be
Go ahead.
x squared minus...
Okay, now what I would suggest you do on these is plug in parentheses what they want you to plug in.
Oh, so it would be negative, or parentheses, -3 times x.
No,
Squared.
squared.
Or just squared.
In other words, all we're doing is plugging in -3 wherever we see x.
Right.
But these minus signs could foul us up here if we don't follow this exactly right.
Right. And then -6 times -3.
Okay, now simplify that.
Okay, so that would be 9 minus, or plus, that would be 18 minus 18. So that would be 9.
Good.
So that would be F.
Uh-huh. Okay, absolute value. Are you familiar? You know absolute value, right?
I think so.
Okay. They want to know what is the absolute value of 1 minus A if A is equal to 12.
Okay.
So what is...
-11?
So 1 minus a is negative 11.
Mm-hmm.
But what is the absolute value of minus 11?
Positive 11?
Uh-huh. That's all absolute value means. It's just whatever sign is on there is positive. Doesn't matter whether it's positive or negative. In other words, the absolute value of plus 11 is also 11, but the absolute value of minus 11 is also plus 11.
Okay.
Okay.
And then, let's see. AB equals C, C equals KB. Oh my, what is this?
Okay, all this other stuff you see here, don't worry about that.
Okay.
Is all that's saying is that we're not going to let you divide by 0.
Mm-hmm. Okay.
So how do we solve for K?
I have no idea.
Well, if AB is equal to C and KB is equal to C, what can you say about AB and KB? It's the same. It's the same C.
Right.
If AB is equal to it and KB is equal to it, then AB has to equal KB.
Okay.
Okay? Now solve that further.
Well, the B's are the same?
Uh-huh. In other words, I can divide both sides by B.
Okay.
Now what am I left with?
A equals K.
Uh-huh. So K equals A, J. And the only reason they have this here is because I can't do this if B could be 0. I can't divide both sides by B unless I know that B can't be 0. And when they told me that BC is not equal to 0, well then B is not 0. Because 0 times any number is 0. So they're telling us that neither B nor C can be 0 with this name. So it's really not pertinent to the problem. I mean, they could have taken that out of there and we still would have solved it exactly the same way. And it's more or less just kind of a, I don't know what to call it. It's what they do in math to protect against division by 0.
Right.
Since that's the first commandment of mathematics.
Right.
Thou shalt not divide by 0. It really is. If you go on the internet and you look up 10 commandments of mathematics, everybody's list is different, but everybody has the same first one. And some of the others are kind of silly, but everybody's first one is thou shalt not divide by 0. Okay, so what is x to the third raised to the 13th power?
B?
No, that would be x to the third times x to the 13th. I would add the exponents.
Oh.
But this is exponentiation going on, not multiplication.
Okay, so it'd be A.
Yes, we would multiply the exponents. In other words, this is the same thing as x to the third times x to the third times x to the third 13 times.
Right.
So I would add 3 13 times, which is the same as multiplying 3 by 13. So.
Okay.
Okay, this is a good one to illustrate lots of good stuff.
Alrighty. Okay. 2x. 1 7. Okay, so
What is the largest possible value of it for x?
So we could try to solve this for x, okay? That could be one
Right.
method. But that's not really the best way to do this problem. For one thing, it's not that easy to solve for x. I can't
Right.
really, because it's an inequality, I can't multiply both sides by x. Because I don't know if x is positive or negative. And if it's negative, I got to turn the inequality sign around. And if it's positive, I got to leave it the same. So it's not real easy to solve this for x.
Right.
But what I can definitely do is back solve it. What is the largest possible value for x that makes this true? Well, if I'm going to back solve it, where am I going to start?
7.
Start with the largest number. If 7 works, which it does, you still won't know the answer.
Right.
Because maybe 14 works, maybe 15 works. If we
Right.
start at the largest possible value of the answers and work our way down, we'll be certain that when we find one that works, we'll have our answer.
Okay.
Does 28 work? Is this a true statement?
No.
Okay. Does 15 work?
No.
Does 14 work?
Yes.
Bingo. We're done that quickly.
Okay.
Back solving is such a terrific technique when it's applicable.
Right.
Remember, your goal here is not to convince anybody how much mathematics you know.
Right.
The goal in the ACT is to get the best score possible, no matter what you have to do. Well, I don't mean cheating, but I mean whatever technique you have to use, whether you know the math or not, it doesn't matter.
Right.
You didn't need to know the math here. You just had to test these, and you found that 14 is the largest possible one that works.
Right. Okay.
So I got 12 of these.
Right.
What's the degree measure of 5 of them?
Of 5 of them combined?
Uh-huh.
So wouldn't it be like 360 divided by 5?
Very good.
And that would be... That would be 72.
Hold on a moment.
Yeah.
No, it's not. It's not 360 divided by 5.
Oh.
Because, let's do it a different way, and you'll see why it isn't this.
Okay.
What is the measurement of each sector?
Okay.
How many sectors are there?
12.
What's the measure of each sector?
I don't know.
360 divided by 12.
Oh, 360 divided by 12 is 30.
Okay, so every one is 30. How much are 5 of them?
Oh, so 30 times 5.
Right.
And that would be 150.
Right.
Okay.
Okay? And that's really the way to do it. Notice that 46 pi had nothing to do with anything.
Right.
All we needed was to know that the whole of the circle is 360. And
Right.
actually, if we took 360 and multiplied it by 5/12, that would also give us the answer.
Right.
That also gives you 150. And it should, because 5 sectors represent 5/12 of the circle, right?
Mhm.
So 5/12 times 360 is actually the most direct way to do it.
Okay. Okay.
But don't worry too much about the fastest way to do these. The most important thing is to get the right answer. As
Right.
long as you can average less than a minute per question.
Right.
Otherwise, you won't get through all 60 of them. They do get harder.
Right.
Okay. Every day at 6:30 a.m. during Wednesday week, Rachel and last counter. Okay.
So how are we going to get the average?
Don't you add them all up and then divide by 5?
Yep.
Okay, so.
And you guess without doing that.
Okay.
In other words, if it was like some of the other questions we've seen, and you know they had 900, 800, 700, 434, that would be the answer.
Okay.
On this one, we can't do that because they put all the answers too close together.
Right.
Although, if I had to guess, I would guess that one. But there's no reason to guess. They let you use a calculator. You can certainly use it. This is probably one of the few problems where a calculator is actually useful.
Yeah,
Most-
it would be G.
Okay, so you added them all up and divided. Yeah. Again, information is completely irrelevant. The time.
Right.
Also, the fact that there are 7 sentences to the question doesn't make it tough.
Yeah.
Don't assume that the longer the question, the more tough it is. That's not always
Right.
true. Frequently, it's not true.
Mm-hmm.
It would be a mistake to take the test assuming that that's a hard problem because it was so long.
Mm-hmm. Alright, which of the following equations has both x equals -3 and let's see, would it be
If I had the
would
following.
it be A?
Yeah.
Because don't you like when you have like the x-intercepts, like don't you change them?
Well, here's what happens. Let's make sure you understand exactly what is going on here.
Mm-hmm.
Because they're multiplied together equaling 0, one of them
Right.
has to be 0.
You're right, that's what I meant.
I solve it by setting it equal to 0, and that solves for that.
Yeah, that's what I meant.
Yeah. Okay.
Yeah. So it'd be A.
Uh-huh.
Okay, yeah, I knew what I was doing.
Yeah, no, I thought so.
Mm-hmm.
Okay.
Alright. I'm not quite sure what it's asking.
It's asking, what do you get if you simplify this expression?
Oh. So that would be 5 times x minus 10.
Hold on. Start by simplifying that. PEMDAS, get rid of the parentheses.
I don't know.
Tell me what that is equal to.
Be negative 2x plus 20.
Now simplify that.
Okay, so that would be, well, okay, so then that'd be negative 2x plus 27.
H.
Yeah, so H. Okay.
So that was actually very easy.
Right.
Now, I can kind of understand why you were a little confused, just the way they asked it. But
Right.
what would be helpful would be to glance at the answers
Mm-hmm.
and try to figure out that, oh, if I just distribute this and simplify, I'll have something that looks like something like this.
Right. Okay.
Two ways to do this problem.
Right.
Set it up algebraically, which is the way I would do it, I think, but maybe not. It's actually easier to back solve.
To what? I'm sorry?
Back solve?
Right.
First of all, what does of mean? What does 60% of x mean?
Divide?
Multiply. Of is always multiply.
Okay.
So 60% times x equals 90.
Okay.
How do I solve that? Or back solve it?
0.6 times 90?
Well, yeah, that's the first thing. Change that to a 0.6. So 0.6x equals 90. How do I solve that?
Do you put them both over 100?
No. You got it halfway solved. The only thing you have is a coefficient in front of the x.
So x equal, divide.
Okay.
Yeah.
What is that number?
150.
Okay. Now when I said back solve it, what I meant was that rather than setting up the algebraic equation, let's look at their answers. What is 60% of 1,500? Well, 60% is more than half, so it certainly isn't 90.
Right.
What is 60% of 150? It's got to be greater than, that's 90. But I could eliminate C, B, and A just because I know that 60% of X, it can't be less than 90. Not if 60% of it equals 90, then X has to be a number bigger than 90. So the only two numbers I really need to consider are D and E, if I know that.
Gotcha, okay.
And I'm not going to do E. That's huge.
Right.
So I'm going to try D as my first one, and it's going to work, and I'm done.
Okay.
So even on this problem, back solving is faster.
All right. The price of one box of popcorn and a drink together is $5.10. The price of 2 boxes of popcorn and 1 drink together is $8.35. What is the cost of 1 drink? Okay, so it has to be less than $5.10.
For sure.
Okay.
For sure. But all those answers are less than 5.10. Now, we could solve this algebraically, but we would have to define 2 variables. One would be the price of popcorn, the other would be the price of 1 drink.
Right.
We'd set up 2 equations, and we'd have 2 equations and solve for both variables. Okay, that's very doable. But let's consider back solving this, even though it's a little tougher to back solve this. Still not impossible.
Right.
Let's start with G.
Okay.
And the reason will become apparent here in a second. We're going to say one drink costs $1.85.
Okay.
Now, does this paragraph make sense if that is true? Well, what would a box of popcorn cost?
What, or 510 minus 185?
Why can I not do addition all of a sudden? Yeah, that's a 510. So if the cost of one drink is $1.85, then the cost of one popcorn is $3.25.
Right.
Now let's see if the second sentence makes sense. What would the cost of 2 boxes of popcorn and one drink be?
Okay, so you do the
2 popcorn.
325. Yeah.
That would be $6.50 because I'm going to multiply that by 2. I'm going to add the cost of a drink,
Right.
and I get $8.35. Bingo.
So it does work. Okay.
Now, why did we start with G? Why didn't we start with F?
Because F is too low for it to add
Well,
up to.
no, there's a reason. And that when you use back solving to solve these, frequently you can tell whether you need a bigger or a smaller price.
Right.
Let's say that $1.85 wasn't the answer,
Mhm.
and I got some price that was $7.
Right.
That would tell me that I need a bigger number, not a smaller one.
Right.
So I wouldn't have to try the 75-cent one.
Right.
If 185 wasn't correct, I would next try 255.
Okay.
That's going to tell me the answer, because either that's the answer, or I'll need a bigger number, in which case I'll know this is the answer, or I'll need a smaller number, in which case I'll know this is the answer. So by starting with the second low or the second high, you are guaranteed that you're only going to have to try 2 numbers. In other words, I'm only going to have to go through this math twice, at most. I'm never going to have to check all 5 answers.
All right.
And I think this was probably easier than setting up 2 equations and solving that system of equations.
Right. All right.
So what's the first thing you have to figure out?
Well, if you're buying 2 lamps, you need to do $8.99 twice.
Okay. Should be $17.98.
Right.
Then what?
98. Okay, and then you should divide by 0.7.
No, remember?
No, subtract by 0.7.
Well, remember when
Multiply,
we did?
Sorry. Multiply.
Okay. Multiply by what?
0.7.
0.07.
Okay, 0.7.
Okay, and then add that to the 1798. Or, what was the easier way I said to do it earlier?
Backslash.
No, multiply by 1.07, and that'll give us the exact price, including tax.
Right.
In other words, this is the same as multiplying by 0.07 and adding it to 1798. Only the first way is 2 steps, and this is 1 step. So what do you get for the total price?
Wait, so you multiply 17.98
Uh-huh.
times 1.07?
Right. In other
That'd
words,
be
go ahead.
that'd be 1923.
Okay, now read the rest of the question, the bottom two sentences, and give me the answer.
You have $20 or you have $21 bills. How much will you need to in coins if you want to have exact change ready? Okay, so you subtract that from 20,
No?
right? No?
If you walk into the store and you have $21 bills
Mhm.
and the bill is $19.23 and you have some change in your pocket, how much exact change do you need? 23 cents.
Oh, okay.
Now, the reason that isn't on there is because you had a round-off error when you did the multiplication,
Right.
and that actually is 1924.
Right. Okay, so it'd be A.
Okay? So, yeah, A is the answer, but notice what this question is not. It is not, you give her a $20 bill, how much change do you get? And that answer is on there, 76 cents.
You're right.
Half the people taking this test are going to answer 76 cents because they don't read the question exact enough. They just assume that you gave her $20. How much change? Well, that's not at all what they're asking.
Right.
All right.
Okay, so r to the third equals 343, then 3r equals what? Oh, I don't know.
Well, let's solve for r. If we can figure out what r is, then we'll know what 3r is.
Okay, so r equals, how do you do this? I don't know how.
If to take the cube root on a calculator, in other words, we need to take the cube root of both sides, right? This is essentially what we need to do. We need to exponentiate the left side to 1/3 and do the same thing to the right side.
So you would just do
343 raised to the 1/3 power. What do you get?
Let's see if my phone will let me do that.
Raise it to the
7.
Okay. And what is 3r?
Would that be?
If r is
Oh,
7.
so that would be 7 times 3, so that'd be 21.
Good. It feels to me like you're making these overly hard.
Yeah.
In other words, you're looking for a hard problem, and most of them so far have been quite easy.
Right.
Okay, rank these three numbers from least to greatest. Tell me how you're going to do it. What's the best way to rank them?
I have no idea.
Put them all in decimal.
Okay.
And then it'll be easy, right?
Right.
What's pi?
3.14.
What's 7/3? You only need the first digit.
7?
Do it on your phone.
7 divided by 3. 2.3.
And what is 9/2?
4.5.
Now it's a piece of cake.
Right.
Smallest, next.
Because least to greatest.
Uh-huh.
So it'd be 7/3, and then pi, and then 9/2.
Which is B.
Right.
Okay. Good. Making pretty good progress through these, actually. Speed-wise.
Yeah.
words, I've got a fraction 9/13 that is not the same as 3/4. But if I add a number to both the numerator and the denominator, it will be the same as 3/4.
Right.
So how am I going to solve it?
Would you, I'm not sure.
So what was you going to say? You were going to say it.
I have no idea.
You were going to say, would you back solve it?
Yeah.
And yes, you would. I
Okay.
want you to always think of that as the first way to solve these problems. Can I back solve it?
Okay.
Can you back solve it?
Yes.
Okay. Pick an answer. We'll see if it works.
-3.
Okay. So 9 minus 3 over 13 minus 3 equals 6/10. Is that 3/4?
No.
Okay. Pick another one.
Sorry. -1 and 1/4.
The math's going to be hard on that.
I don't want to do that one.
That's exactly right. You don't want to choose it because there's no more likelihood that that would be correct than this one here.
Right.
So let's do the easy ones. Pick one of those two.
Okay.
Okay, so plus 6, that would be 15 over 19. Is that the same as 3/4?
No.
Okay. The only other easy number to pick is 3.
Right.
What's that?
12/16.
Which is also,
3/4.
there's the answer.
Gotcha.
Okay. Now, if we wanted to solve that algebraically, it wouldn't be that hard, but it's not something that people, x would be the number, and that would have to equal 3/4, and then I just have to solve this equation. There's only one variable there, x, so I could solve it for x easy enough. But again, back solving was a lot easier.
Right.
As long as one of the answers wasn't this. Now, I didn't have you start with the second lowest and the second highest because we weren't really going to know whether we needed to go up or down. In other words, when we back solved it and we tried 6, that didn't really tell me that I need a number less than 6. I mean, other than the fact that all the other answers are less than 6.
Right.
So when you're back solving and you're not going to be able to know the direction that you need to go if you don't happen to pick it on your first pick, it doesn't really matter where you start.
Okay.
Unless it had, remember that question that it said, what is the greatest number? In that case, you're going to start with the biggest number and work down.
Right.
If the question says, what is the smallest number, you're going to start with the smallest number and work up.
Right. Okay.
So the method of which one you start with is quite important as to what numbers you start with. When I first started working with these tests, I always started with the number that allowed me to do the math the easiest.
Right.
But I found out very quickly that on the ones where you know what direction you're going to go, that's not the best way to do it. You want to start with the second lowest or the second highest, and then go from there.
Okay. All right.
What's the slope between those 2 points? I know you know this one because we've been working on this.
Right, it'd be y1 minus y2 over x1 minus x2. No, x2 minus x1.
Don't switch them up. It doesn't matter as long as you go the same way with both. You can't do y1 minus y2 all over x2 minus x1.
Right, so it'd be y2 over, or y2 minus y1.
Well, give me numbers.
Okay, hold on. Okay, so 7 minus 2.
Okay, that's a minus 7.
Oh, that's a 4,
That's the
sorry.
x. That's x and y.
Yeah,
That's
sorry.
x and y.
So, negative 7 and minus 4 over 2 minus 5.
Okay, what's that?
And that'd be negative 11 over negative 3.
So what's the answer?
Wait.
Negative divided by a negative is a positive. So that's the
Oh, okay.
same as 11 thirds.
That'd be B.
Yes.
Okay.
Okay. Okay, don't get scared by the prime factors. These are actually pretty easy.
Okay. 38 and F is the greatest prime factor.
Give me the prime factors of 38. Using a tree.
Okay, so trying to think.
Split it in half. Split it in half for starters.
Okay, so that would be 14? 19.
Okay. Now the fact that both of these are prime, meaning I'm done. I can't split 19 anymore.
Right.
So 19 is the greatest prime factor of 38.
Right.
Now let's do the same thing with 100.
Alright, so that would be
Just split it in half.
50 and 2. No, yeah.
2 is prime, but 50 is not. So 50 can be split again.
25 and 2.
25 is not prime.
5 and 5.
So what's the greatest prime factor of 100?
2. Right?
5.
Or 5. Okay.
In other words, the prime factors of 100 are 5 and 2. It's 5 times 5 times 2 times 2,
Okay.
but all 4 of those are the prime factors of 100. And the large,
Okay, so that you would add 5 plus 2 and that'd be 7.
you'd add 5 plus 19
Oh,
because
okay.
it wants the greatest prime factor of 38 added to the greatest prime factor of 100. Well,
Okay.
19 was the greatest prime factor of 38. 5 is the greatest prime factor of 100. The two of them add to 24.
Right.
All right. Let's try to get one more in here at least.
Alright. Or 25. T plus V squared equals 289. TV equals 30. And T squared plus... Okay. Alright, so T times V equals 30.
Hmm?
So...
What's my first step here? What's the only thing you can do? There really isn't anything else to do as a first step.
back solve?
No? Well, this is a little tougher to back solve. Because
Okay.
what am I going to do? If I assume that t squared plus v squared is 61, where do I go from there? So
Right.
this is not a back solving problem.
Okay.
But there's an obvious first step here. When I'm looking at this, there's only one thing I can do. What is it? Well, I should take that back. There's actually two things you could do. You could take the square root of both sides, but that's not the way to go.
Would you find the factors of 30 and plug it in for T and V?
No. Expand this. FOIL t plus v squared. What do you get? In other words, when you look at that, there's really only one thing to do. Multiply that out.
Right.
if you use PEMDAS, get rid of the parentheses and then do the exponents.
Okay, so that would be t squared plus tv.
Okay, you're foiling it. That's fine. I'd rather you do it based on your knowledge of a plus b quantity squared. Remember, I've tried to get you to memorize that.
Yeah, it hasn't stuck.
All right, you can do it foiling it. That's fine.
Okay.
Next term. The reason I've tried to get you to memorize it is so that you would save 20 seconds every problem that you take on the ACT.
Right. And then it'd be b squared?
No, there's another TV. In other words,
Okay.
this is the first, this is the outside terms, this is the inside terms,
right.
and the last term is v squared.
Okay.
Okay, simplify that.
So that would be t squared plus v squared plus tvb or 2tv.
I got one TV, I got another TV, I got two TVs.
Right, okay.
No pun intended.
Okay.
Actually, I have one TV. Okay, so, and they've told us that this whole thing is equal to 289, so I can say that's equal to 289.
Right.
And they want to know what this is equal to.
Right.
So now what do we need? TV
I'm not sure.
TV equals 30.
So that'd be 2 times 30.
So I'm going to add 60 to my t squared plus v squared. That's equal to 289.
And then you subtract 60 from both sides.
So now t squared plus v squared equals 229. That's what they were asking about, was t squared plus v squared.
Oh, okay. There we go. All right.
Okay, now notice that if I did the only other thing that I could think of doing, which would be to take the square root of both sides, that's not going to get me very far. What is it going to give me? It's going to tell me what t plus v is. T plus v would be, what's the square root of 289? I think that's 17 or something. But even if it was, what do I do now? I still don't know what t squared plus v squared is. Oh, yes, I mean, no, I wouldn't. I wouldn't know. The only way to really solve this is to expand it first.
Right.
And you can see that because you can see that when you expand that, there's going to be a t squared and a v squared as part of that expression.
Okay.
All right. All right. Let's stop at 25. And
All right.
let's see. Are we meeting next Wednesday night online?
Yeah, if you want to do more ACT practice. Well, actually next week I'm on spring break.
I know. That's why I was asking. I wasn't sure whether you wanted a session or not.
Let me talk to my dad, and I will either text you or call you.
Okay. That's fine.
Let me just talk to him. So
I will not have you on there. There's not going to be any problem getting an appointment next week because everybody's on spring break. So my week is pretty empty. So if you want an appointment, just call me. Otherwise, I'll plan on not giving
okay.
one. Okay?
Okay, that sounds good.
All right. Enjoy your spring break. And if I don't talk to you next Wednesday, we'll have a session 2 weeks from tonight. And we'll do that online also?
Yes.
Okay, good.
All right. Well, thank you so much.
You're welcome. Have a good evening.
All right, you too.
All right. Just X out of this go to meeting thing, and that'll close out your session.